infrastructure engineer for GitHub, and I'm based in Seattle. And really, this is the first time I've been to LA in a long time. What I know from LA is like 80s movies, so I know your traffic is bad and you never order on menu. It's pretty much all I know, especially being in Hollywood, you know. So we've got a really strong food truck scene in Seattle. And so yesterday I was in line for the Tropic Caribbean food truck, and I saw somebody try to order off menu. I thought, man, what a jerk. Yeah, somebody down here got it. You don't want to try that move at a coffee shop because you'll get a lot of feedback from a latte feedback from the barista. I saw someone do it at the Mediterranean truck, and I was going to stop them, but I didn't want to be a Euro. I work with Tenderlove. Some people know my story. I'm an accidental software developer. I went to school for performance production. I was all set to go be a Shakespearean designer. I worked in lighting design and a little bit in sound, and then Fish broke up and I had to get a real job. And so, I've always been really curious about what it means to be a developer, because it took me a long, long time to consider myself a developer. And I've been in this game now for 20 years. Well, I guess technically 19 because I took a year off and went and played poker. How many people here are self-taught? Just out of curiosity. Yeah, it's about 40% of the room, which is a little bit lower than like at like an application developer conference, but this is more systems oriented. I think there's probably a little bit more comp sci backgrounds for people. This may surprise you, so hang on. I went to a hippie school, Goddard College. Go Moonbats. It is, in fact, one of those schools. We like to say about Goddard is that Goddard is just like a college. Goddard College, excuse me, was founded in 1938, based on primarily the teaching philosophies of John Dewey, which is democratic education through hands-on work. And one of the core philosophies that's in his mission statement is, and I have to read this because I'm a Goddard student, I can't memorize it. We challenge ourselves and each other to embrace uncertainty, experiment, and imagine unexpected outcomes. And I love that. I love that. Goddard's entire philosophy is like, you want to learn something? Go learn it. Go find some books. Go find somebody who knows more about it than you and talk to them and go explore and educate yourself and enrich the world around you through hands-on engagement with the work. And I think this was actually pretty much the perfect school for me to go to. As Chris said, I collect hobbies. I went to cooking school for about 3 weeks before I decided I hated getting up at 3 a.m. I was a professional poker player for a year. I think tonight I might sneak down to the bike. I do glassworking. I've been a hiker. I interned in a marionette puppet theater company for a while. And I recently took up yo-yoing. I'm a thrower, I guess is the term. I've got a serious yo-yo addiction going on right now. And I like to tell people about these things, not just to say how cool I am, but also that I find myself really often in this place of not knowing what the hell I'm doing, being an absolute beginner and novice, newly arriving into a place where there's established people and norms and best practices, and I've got to like constantly raise my hand and ask really dumb questions. And it's especially hard when people think that you're really, really smart and you know stuff already, and you're like, what's a server? That can be really, really hard. My dad, he worked for the same company. He started there when he was 16, and he retired a few years ago at the age of 63. He worked for the same company for his entire life. And so he, for a long time, was like, what are you doing? Like, you change your mind every couple of years. You're at a new company, or you're following a new career path, or you're doing something new that's like you're super, super into. And I kind of got it from him because he started a beekeeping company and a metal detector supply company, and he started a black and white photography studio in our house, and so I kind of got it from him. And the other thing I picked up from him is a love of motorcycles. I don't have a motorcycle right now, but I ride and fix vintage Vespas. And when my dad found out about this, he was like, "Oh, that's great. We can bond about something at last." This is the first Vespa I ever had. This is a 1979 P200. So that's been around almost 40 years. It's almost older than I am. And so it's constantly breaking down. This is my current ride. It's a 2008 Stella 2-stroke. Trust me, the scooter people, they love this stuff. No, I got it for $1,300. It, occasionally it's going to break down. I got to do periodic maintenance because there's these really finicky engines that were invented in the wake of World War II. The Italian aircraft and the military machines looking for new things to do, and they settled on scooters. They're cheap, they're economical, they're easy to build, and you could use all of your aluminum crafting skills that you picked up during the war to build really lightweight machines. Unfortunately, the inside of an engine is kind of like this. This is also the Rails active record model. And so after numerous frustrating breakdowns, I was talking to my dad about having to take the engine apart and fixing it, and he reminded me of something that he had taught me when I was a kid. He was trying to teach me about car engines, and it never stuck, but this idea did. He said there's only 4 things that a car engine, or really any internal combustion engine needs. It needs fuel, it needs air, it needs a spark, and it needs pressure. And if the engine doesn't work, one of those 4 things is missing. That's it. Now, there's a lot of extra stuff that's going on in there, right? Like your windshield wipers and your fuel injectors and all of this other business. But really, it boils down to these 4 things. It's a very simple binary tree when you break it down. Like, do I have fuel? Yes, no. Okay, well, I can eliminate that. Is the air intake valve open? Yes or no? And you can get constantly more and more complicated, but it forces you to start at this very high level of understanding very simple root causes to problems that you're facing. This one time, I'm out I'm fixing my Vespa, and I clean out the fuel injectors, and put everything back together, and I kickstart it. It's going great. And I'm like, sweet. I get out and I ride. Half a mile down the road, the engine conks out. I'm like, okay, well, it's got to be one of these 4 things. And so I start looking at the usual hierarchy of blame. What did I last touch on this engine? I last touched the fuel injectors. It has to be the fuel injectors. So I rip apart the carburetor. I'm looking at them. Nope, they're all in there. Everything's adjusted fine. Maybe I got some cleaning fluid into the gas line. That would be horrible. Or maybe there's some gunk that got in. Or maybe my spark plugs are now fouled from this. Maybe I'm running too rich. No, 30 minutes later, I realized I had just run out of gas. Because I broke the cardinal rule. I broke the rule of starting at the very, very high level of what the obvious things are. Does it have gas, yes or no? And then I went down immediately to thinking I knew exactly what the problem was and trying to solve it that way. This kind of technique of starting at this sort of level and working your way down to more and more specific, from obvious to less obvious causes, is one of the techniques that Goddard taught me about education and about how to learn something, of starting at these very broad ideas and broad topics. And it's part of building your own toolkit for inquiry, is to acquire these skills and these techniques. We pretty much have all kind of come across the scientific method before. Anyone not know what the scientific method is? No other Goddard students here, okay. You have to appreciate that the joke about Goddard is, why did the Goddard student cross the road? To get credit. So the scientific method is one of these tools that we can put into our toolbox for diagnosing problems, and whether we're diagnosing a problem or just exploring code itself. First thing is we want to ask ourselves a question, and defining a problem simply through asking ourselves, what do we expect to happen? What is actually happening? And what does success actually look like? What do we expect to know at the end of this process? And having a very simple definition of the problem, do I have fuel or not, helps us to avoid fear or panic, and it helps to sort of organize all the different yaks we're going to be shaving along the way. Doing your background research is really important. When you first engage with software, maybe you don't know it, or you might not have touched it in quite some time. So where are the playbooks and the readmes? Where's that bibliography of the code? Where are the people, the local experts that you can go call on? Maybe the people who wrote it, maybe they're on another team now and you've inherited it, but maybe are they in the same time? Are they in a time zone where you can get at them on Slack? Identifying these people early. You don't have to necessarily bother them, but just knowing that they're there and available. Finding out your resources for solving things. Constructing your hypothesis, likely especially in a availability event, which is such a polite phrase. We have an availability event. Likely you're going to have multiple ideas of what the problem could be, and you'll have different people working on different aspects of it. If you're starting in a process like this where you're framing your questions very simply, you can have different hypotheses and have different people working in parallel to try and solve a problem. But in this step, you can look at those immediate inputs. What values are you expecting? If you're expecting air and fuel and one of those is water, maybe that's your problem. You want to test these sorts of things. And I used to teach at boot camps and code schools, and I'd always see junior developers make this mistake of changing two things and then reloading the page and oh, it works now, and moving on. That's not really what you want to do, and especially if you're a more senior developer, you probably know this, but it's change one thing and then recompile, right? Just do one factor at a time, because you need to limit the number of variables so you actually understand what the results are in your situation. Then you want to get down to that analyzing the data and drawing a conclusion. And I love this step of software because this is the time where we pause and we begin to reflect on what we've done. And this is the first thing that goes out the window in a crisis situation. But if you can find time in those somewhere in your timeline to actually analyze what happened, right? What data did we gather? Did we break anything else? What choices are we making to solve this immediate problem that we're going to have to come back and fix later on? And how do we account for those sorts of things? And who owns the postmortem? Who owns the write-up? Getting those people involved. This is a really huge step because, well, in the poker world, what separates winners from losers isn't necessarily how well you play or how lucky you get. It's what you do in the wake of playing a hand of poker. And a loser will play a hand of poker and win or lose and be happy or sad and go on with their life. And a winner, no matter whether you've won or lost, you take that home and you think about it and you process it. And you think obsessively about it and the angles. And you reflect on it and you integrate that knowledge. And you create these little incremental pieces of mastery over time. And software is really a lot like that, right? If I just fix something and I don't know why it fixed itself, it's going to happen again. Maybe not today, maybe not tomorrow, but it will happen again later on. And so I have to really integrate the wisdom and the knowledge that I picked up. The last step of the scientific method, is publish, or maybe it's apply for more grants. Having to explain the results of a process to somebody else is amazingly powerful tool for leveling up. They say that teaching something is a really powerful learning tool for yourself. And if you have to go through and explain the results of an experiment or a troubleshooting situation to somebody via postmortems or write up a blog post or just even adding notes to an issue, that can really solidify that knowledge, because now you're having to translate out your experience into communication. That engages different parts of your brain and can lay down pathways that will reinforce the wisdom that you hopefully have gained in the situation. We fool ourselves all the time into assuming obscure reasons for an error, but really the vast majority of the time the solution to most bugs seems to be about 6 characters or less. We just have to force the encoding, or I typoed that thing. Asking questions about it and having this sort of sense of inquiry, of relentless, disciplined inquiry into the situations that we find ourselves in, helps us define what it is that we actually know and what it is that we actually don't know. And if we find ourselves having the answers all the time, we're asking really boring questions. We should be asking questions that challenge us, questions that we don't necessarily understand. the solution to. And especially when I'm doing something that's very rote, if I'm just like, oh, I got to make another model, or oh, I got to write another migration, that's an opportunity for me to play with that moment and see, maybe go a little deeper this time, to like research perhaps something about it that I just assume and I take for granted all the time. Because when we level up from experiences, not just having those experiences, but actually integrating them and being alive in that moment and experiencing it. Because the truth is as our systems get more and more complex, these systems are still built for solving a human problem. There's a human involved somewhere in here. Even if it's a system talking to a system talking to a system, there's still a human in there. There's no closed loops that don't involve humanity. And we humans are far and away the most complicated piece of any system. We're the ones that type in weird Unicode characters. We're the ones that name our children Bobby drop tables. We're the ones that accidentally bump into racks and unplug things all the time. And so we have to maintain a perspective on ourselves as developers to understand where we are in the process of troubleshooting. The way that most people experience new things is kind of like this. You're going along, everything's hunky-dory, and then there's a problem. Or you have to go learn a new language. Or you're off on a different team, or some event happens, right? And you have to live in this land, the sort of valley of despair for a little while. And it can become a very negative experience for most people. If you're not comfortable with uncertainty, if you're not comfortable asking questions and appearing to be dumb, as it were. Because eventually, we find that most people, after a period of chaos and turmoil, come out of that and they accelerate up into a new plateau of knowledge and learning. And a new sense of normalcy can set in. But the problem is that we have a set of expectations for ourselves that this is where I was, or this is where I am, or this is where people expect me to be. But I'm not operating at that level. I'm not able to write code as fast. I'm committing more bugs than I should be. My code is leaking memory left and right when it shouldn't be. And when we're operating below this waterline, it feels a little bit like we're drowning. And when we're in that zone, especially if you see this in other people, you can start to recognize it in yourself, because almost everybody goes through this. People's language becomes negative. Self-doubt comes into play. This is a place where we start to see our best engineers starting to feel burnout because they're not performing well. They're feeling the struggle of having to go through things day in and day out. In the poker world, there's this guy. There's a lot of guys, but there's this one guy. His name's Mike Caro. He names everything after himself. He wrote a book called Mike Caro's Big Book of Poker Tells. And it's kind of a classic in the poker world for, like, what happens when somebody looks up and to the left, and what do they mean when they scratch their nose? That kind of classic movie trope poker tells. And he posited this theory, and of course he named it after himself. He named it Caro's Theory of Misery. And the basic idea is this. Say you're a poker player who's perfectly comfortable losing $1,500. I'm not comfortable losing $1,500, but for the sake of the example, say we are. And so we go out to play, and we sit down, and we start losing. We lose $500, $1,100. And then before we know it, we've gone past $1,500. Now we've lost $1,800. But the table's good, so we stick around. We have a reason to. Hours and hours go by, and things get worse and worse and worse. And now, instead of being down $1,800, now we've lost $4,000, $5,000. And it's at this point where additional losses simply don't register anymore. Pain has been maximized, and we're numb to any additional pressure. Nothing else registers. So the threshold of misery is this point that we can get to where things have become so bad, we simply cease to care when they get worse. And this manifests in not just in our poker world or our technical lives, but in our personal lives, it can manifest as, well, I've overslept by 2 hours, so I might as well call in sick today. Or, I'm really not supposed to be eating candy, but I had a lifesaver, so I'm going to eat a whole candy bar. These ideas that, like, things are just so bad, we're just going to go ahead and just plow through. This is something that's coming into play when I see people do things like, well, I know I should refactor this massive if-else block into a bunch of, case statements or something, but I'm just going to tack another another else case on, and it'll be okay. Or, I know I really should write tests, but it's too hard. I'll do it tomorrow. Or, you know, if I just add a little more jQuery, it's only 200K, and the front page is already 4 meg, so like no one's going to notice. And these sorts of things aren't necessarily, well, I think they are a little bit unprofessional, but these aren't choices made from a sense of unprofessionality or ignorance or certainly not malice, but they're from somebody who's living in this place of misery. It's not just individuals that can stand teetering on the edge of simply not caring anymore, but teams and entire organizations can be poisoned by this sort of sense that nothing they do matters, and there's no way that they can make any sort of difference in their surroundings. And this is the unfortunate place where we start to lose not just our best engineers, but our own personal best work. We have to be aware that when we're in this threshold place, because we think that the decisions we're making in this moment don't matter. It doesn't matter. The code's already crap, so I'm just going to add more crap to it. Except our decisions do matter. They matter every single day, and we'll thank ourselves sometime in the future if we can maintain that perspective to make good choices. So as we're troubleshooting code, let's not make short-term choices just to stop the pain of being in an availability event, choices that leave us vulnerable later on. The secret is to keep performing as if we care, to pretend to be somebody who cares, and eventually we will. Being a successful engineer, you have to kind of hold this particular weird trick in your brain. You have to assume that you have to have this aggressive belief in your own abilities, that you can solve anything, that you can crack any nut that comes along. And you also have to be humble. You have to be self-analytical about what your limitations really are and where you need to learn more. Self-analyze, was your process solid? What mistakes did you make? How can you perform better? And this is a weird dichotomy. Because, again, as often as not, we're that most complex thing that's interacting with it. And now we're trying to run this complex paradox inside of our own weird little brains. But I find comfort in chaos. Frank Lance, the director of NYU's Game Center, was an exec at Zynga. I don't think he is anymore. I don't think there's any execs at Zynga. He gave a talk a few years ago at a GDC and talking specifically about poker and Go and the differences between them. Go is a game of perfect information. I know exactly what moves you can make, and I can see what moves you have made. It can be solved by a computer. Poker, on the other hand, I don't know how much you're going to bet. I don't know what your cards are. I don't know what the remaining cards in the deck are. It's a game of imperfect information. In a situation of imperfect information, you are only able really to see the world as a series of overlapping probabilities, a smear of Bayesian logic. When everything becomes a possibility, you survive not by sorting the possible from the impossible, but the probable from the improbable. Whenever I hear somebody say, well, the computer shouldn't do that. Well, clearly it is. So let's say it is improbable and move on from there. When we're debugging a problem, we often can't actually test the precise situation. Sometimes we know. Sometimes, we've got the stack trace, or we've got all of the inputs and all of the expected outputs, and we can see that delta, and we can understand and we can reproduce it. But sometimes we can't. Even with enough time and the perfect tooling, we can only diagnose problems through their side effects. How one system crashes into another, which crashes into a third system, and then we've got a bug 4 systems down the stack. So in this place of incomplete information uncertainty, we assemble data points to construct a narrative of what we believe to be true. We need to build an understanding of how our own brains fill in the gaps of knowledge and how we can fool ourselves into pitfalls of bias and assumptions, these quagmires that slow us down or have us chasing our own tails. We have to tell a story about all these different data points and how they fit together. And the story we tell has to make sense. It has to be consistent. We have to understand what that story means. Because if we can't understand what a thing means, and we look only at what it is, we look at the data points, but not what those data points actually mean, we're hobbling our ability to understand the larger complex thing and that the software is in and of itself. As complexity grows, it exposes the limits of our rationality. There simply exists too many states, too many interactions for our testing to ever be considered truly comprehensive. And tests themselves don't comprehend anything. They only say, this is what I know. This is what I believe to be true about the ways this software can let me down. And the software will always find a new way to let you down. The two kinds of complexity, applied and inherent, we can factor away the implied complexity, the complexity that we bring into the crafting of the code. But it's really difficult to sometimes get rid of that inherent complexity, the complexity that's just there because of the thing in and of itself, the noumenon of Kant. Every meta-programming solution I've ever seen, yes, it solves some applied, but it creates inherent complexity, for example. Code is existing as a set of reactions to states, to inputs. It's a series of instructions. Computers are dumb little children who only do what we tell them to do. And every time they have a problem, they raise their hand screaming for an adult. Because of that, an error case reveals something that we don't know, something we've never thought of, or something we thought was rarer than it really is. An error case is something new, and it's shiny. We're pushed into a place of discovery. We're presented with the proof of our insufficiencies. And as developers making inevitable human mistakes in syntax control flow or other errors, our understanding of the process required for that code to successfully achieve the goal we had in mind changes. The code itself is responding constantly to the pressures of the world around it. Just like an evolutionary creature, the things that are bad about a piece of code were good at some point, or they were the best attempts that somebody made. And the environment that that code existed on certainly wasn't applying any evolutionary pressure to make that a maladaptation. So scattered among your code base today are appendices, things that are going to swell and burst at some point. But why take them out? We don't take out appendices at birth. We could, but we don't. Because we don't have to until it becomes a problem. So similarly, we don't often fix the code until it becomes a problem. Can I tell you a bad story? A really horrible story about how I almost broke a company? Okay, so years ago, a company that I worked for, a hosting company, had been around for a number of years. It was started by a bunch of Perl hackers and had grown into a fairly large 60, 70-person company doing really, really well. And they sell hosting and virtual servers and it's probably very specialized enterprise stuff. But they also did domain name registration. And one day we got a call from the new CFO of one of our largest clients saying, hey, I noticed that our monthly bill for the last 3 months has been $25,000 higher than it had for the entire rest of our contract with you. Could you explain what happened? So it got down to me, and it came down to domain name registrations. You know those little $15 things that you do? Here's what we did. For every domain name that the client had, first, let's fire up a rescue job, an asynchronous piece of work. We're going to check to make sure we can actually build the client. We're going to build the client on our internal system. Then we're going to use the company that I worked for, our internal credit card to renew the domain. If the registrar returns any sort of error whatsoever, things blow up. Oh, I'm missing a slide there. Not quite so funny now. If the registrar returned any kind of error whatsoever, we would retry 3 times and then give up. We would requeue the job and give up. So, what happens when the company's credit card has expired? When the corporate Amex has expired? We would fail 3 times because our company's credit card would fail. We'd requeue the job, and 5 minutes later, we would bill the company $15, our client $15, attempt to register 3 times with our credit card. It would fail. We'd requeue the job. 5 minutes later, we'd bill that. Yeah, so $25,000 a month later, we had a very, very unhappy client. And I could fix it. And it took me and another developer about 30 hours pairing intensely over the course of 4 days to figure out what the hell the problem is, because it was 400 lines of Perl. Yeah. You know, it was all hyper-optimized and a little bit obfuscated. I think there was some, like, Elvish script in there. And did we really need to offer this service, though, right? We really only had 600 domains, and we made $3 each on them because we had some bulk deal. So, like, you know, I already blew through this thing, so I could refactor it. Or I could take this opportunity to talk to the sales guys. Because it wasn't a problem with the code necessarily. The code is fine. It was broken, but it was the credit card that was broken, right? It wasn't related to technology at all, although there was certainly a flaw in my logic. If a change in our perspective, as Alan Kay said, gives us 80 points of IQ, where does that IQ come from? Is it because we're smarter about how the code works? Or does the change in perspective change the kinds of questions we're asking about what the software is, what it should be doing, and what it could be doing? In this particular case, we had a business need. Let's register some domains. We did that. That's a horrible manual process. Let's automate that. We automated it, and we automated ourselves into an error. That's fine, that's going to happen. But was that a service we really needed to be offering? So by pulling back and reorienting our perspective on the problem, we were able to lower the temperature of the fire that we were sitting in the middle of, just a tiny bit. Because we're all sitting in the middle of dumpster fires, or what we think are dumpster fires that are perfectly fine pieces of software. I don't think Chris mentioned it, but I think I did a little bit. I used to be a stagehand, and so like I get to come up on stage and like see like how technology on the stage has advanced, you know, in the last 15 years. And I was looking at some lights backstage, and they still have the same bolts for logging onto a pipe. And it reminded me of my favorite tool, the Crescent wrench. Absolutely my favorite tool. And I've hauled Crescent wrenches up and down ladders, in genie lifts. I crawled under things. As a stagehand, it was awesome. I've pounded in nails. I jammed open a loading bay door one time so we could get a baby grand piano in and out without having to like bother the security guard. I fixed the jam rear brake on my Vespa one time with it in the middle of the rain. I just hammered it until it fixed. I once jump-started a car with a Crescent wrench by bridging a couple contacts. I don't recommend you do that. Don't ever get shocked by a car battery. It's 12 volts, but electricity is weird. I had somebody hold my beer, of course. But the C-wrench is a super versatile tool, right? I mean, it's really great, and it's simple, and it's really just a big hunk of steel. It's really kind of crude. And I have one in every single toolkit in my life, along with a good multi-tool. Because they're tools that welcome divergent uses, and they ask you to avoid functional fixedness. So functional fixedness is this idea that comes from cognitive psychology. And it's defined as a fixation on the common uses of an object while overlooking entire categories of features of that object. And the canonical example you'll get if you flip through a lot of like freshman cog-psych books is the Titanic. Why didn't the people on the Titanic get on the iceberg? It's there and it's floating. Why didn't they use the iceberg as some sort of flotation device until they could be rescued? And we don't know. But the texts are always posing this as functional fixedness. And idioms and patterns exist for a reason. They're standard ways to solve frequently occurring sets of problems that we face in our day-to-day lives. Best practices are best practices for a reason. But if we never question these idioms, if we never question our approaches, or how well we understand the particular problem that we're actually facing, we become blinded to opportunities for improvement, let alone innovation. Our muscle memory can lead us astray, leads us into situations that involve clever use of familiar tools rather than canonical uses of tools with which we are less comfortable. Cleverness is the opposite of elegance, and elegance is something we all sort of kind of aspire to in this weird way. In development, the same sort of cognitive barriers manifest differently, I grant you. Mental dependencies, unhealthy reliance on idiomatic solutions, and we see it in problems noticing that a piece of code no longer plays the role it was intended to. I can't possibly know what every single line of code in my code base is there for, unless I go out and go looking for it and ask the right questions. So anyway, these techniques, these ideas of applying scientific method to our own biases, managing our relationship not just to the code, but to the people who wrote it, and our own inner struggles grappling with comprehension and understanding, all serve to allow us to become discoverers. Because software didn't just fall out of the sky, right? Human beings wrote it. How many people here are humans? Few of our robot friends have joined us today. Thank you. Humans wrote it. You're human. You can do it. I am 100% behind you and have faith that you can understand any piece of software that you approach. It doesn't matter how smart the person was who wrote it. You can understand it. But you have to be able to be comfortable in this land of discovery. And when you're in this place of discovery, it increases your ability to reason about the nature of software, both in terms of the immediate code and the code as it exists into the future, as well as the past. We are the single constant, bringing our comprehension of the nature of computation to bear when generating solutions to human needs, which themselves exist within the boundaries of humanity. There's no problem that wasn't caused by humans, that wasn't framed by humans, with all of our biases and all of our frailties and all of our failures. By understanding the rationality then of software as well as the human context in which it's created, you can multiply your ability to craft solutions that are increasingly resilient and yet never perfect. So what's the through line? What's the point, Kerri? In our relationship with software and failure, it is in the challenging of our starting point, pushing us from stasis to growth, that we begin to emerge. In a really crude way, we're engaging in the prototypical hero's quest or hero's journey, where we're starting in a place of safety and comfort until something sends us out into the woods, where we encounter a beast or a witch or whatever, which we slay. We seize the treasure or the reward, and we return to our village or our home. But we're forever changed by that experience. We come to a new place. We come full circle back to where we started, but we are no longer the same. It's not that the place has changed. It's that we have changed. We are different. And this is the insufficiency of our ideology. We apply our ideology that we carry with us from task to task, from project to project. And we can change them in and out, like glasses. Slavoj Žižek said that we should imagine ideology as a kind of filter, a frame, so that if you look at the same ordinary reality through this frame, everything changes. But in what sense? It's not that the frame has actually changed or added anything. It's that the frame opens the abyss of suspicion, the suspicion that things might not be the way that we think they are. Žižek was a huge fan of the movie They Live. Have you ever seen this? It stars Roddy Piper. It's the ultimate 80s movie where he finds a box of sunglasses, and every time he puts the sunglasses on, he can see the aliens that live among us. And he spends the whole movie trying to get his, well, not the whole movie, but a good chunk of the movie trying to get his best friend to put on the glasses so he can see the subliminal advertising and the evil zombie aliens as well, and his friend rejects him at every turn. At one point they have this WWF fist fight, over who will he wear the glasses? Will he accept this new ideology and wear it? People resist change because change is scary. Change is chaos. It's not comfortable. I'm a better developer. I'm a really good developer, actually, which is weird for me to say, but I'm actually pretty good. And it's not because I'm the smartest, or I'm the best educated, or I've had the best opportunities in life, although I did grow up with a computer in my home, and I'm white. But specifically because I've made a lot of dumb choices. I've made a lot of mistakes, and I've seen a lot of errors. And my response to it has always been to ask why, and to try to understand why, and to see where what I'm bringing to the code is the problem. Can that be changed? Can that be improved? Because the best tool for debugging or troubleshooting any system in the world, any process, any problem you have in life, already exists inside your own head. Thanks.